You're muted, Sam.
Okay, we're recording. It's good.
Okay, we're recording. Okay, so we're, the next section, we're going to go over files. Like I said, this is going to be quicker than the last section because once we get over strings, the rest of Python is smooth sailing. So VP, Violent Python 110, bytes and files. Let's open this up. So let's see, we are going to try, is this 110? Yeah, bytes and files, okay. We're going to look at what type of data we're looking at in Python. So let's open up a Python shell here, which is already open. It's not handy. So I equals 1. So if we print I, we get 1, because we know it's 1. That's its value. But if we want to figure out what type of data it is, we would use the type function. And I realize I just printed type 1. I'm sorry about that. But we would use type I, and we now know that I is an int. And that's really handy when you are debugging. You're trying to figure out what type of object you're working with. You can use type. And let's see, let's do the same thing with another value. So let's say j equals I plus 1. So if we were to print j, we get 2. But if we want to know what type of data it is, we do type j. We know that it's an int. So let's look at another data type. Let's look at bytes. So if you wanted to do an old school type of string where every string is a byte, you prepend the string with a lowercase b. So let's type C equals b. Let's look at the example used here. We're going to make it we're going to use the escape hex character. So we're going to directly give it a hex value of 1. So we have a byte array containing 1 element, and it is hex 1. So if we were to print C, we have the value of 1. And if we were to do type C, we see that it's going to be a type known as bytes. Let's go back to the page here. Let's say, okay, b equals, so if you wanted to get that byte out, and we were just actually going over this for a question that was asked. Let's say b equals C0. So that's going to take out the first element in our bytes list. So if we print b, we're going to get 1, which is hex for 1 and is the same as decimal 1. And that is going to be an int again. So if we check this out, type b. So we went from a byte to an int. So we can add to a byte and subtract from bytes. So let's do some math on bytes. So let's make a variable called b, and we'll give it a value of hex 12. So if we print b, we see we have a value of hex 12. Okay. Now let's from that bytes object, let's take out that value and turn it into an integer that Python can do mathematical operations on. So let's say I equals, integer equals the first element of our bytes. So if we print I, we're going to get the same value, only it's going to be printed in decimal. So hex 12 is the same as 18 decimal. And now we can do some operations on it. So let's say we want to do I equals I plus 4. Now if we print I again, we see that now is 22. And if we want to put that back into a series of bytes, we would run, I believe is the or, okay, we're going to use the bytes again. So we're going to use bytes I. Throw that back into B. And there we go. We have hex 16, which is the same thing as decimal 22. So that's how we convert between a byte, an integer, and back into bytes. And for all intents and purposes, you can think of bytes objects, like what B is, if we do type B. You can think of this object almost the same as a string, except it does not support Unicode. It's just always it's always bytes. So let's look at files. If you are familiar with files in C or Java, this will be second nature to you. So let's copy and paste this example Python script for creating or reading from a file. And first let's exit out of Python. And let's open up Nano and do pyfile1.py. Let's paste in this example code. So we are going to deal with infile, and this means read as binary, as F. So F, the object F is a file called infile. We're going to read a byte, and while the bytes that we read are not empty, we're going to print it and read the next byte. So let's exit. Yes, we want to save. Enter pyfile1. Okay. We're going to need to make an infile for it to read. So let's open up Nano for a file called infile. We'll just type hello. Save, yes, enter. So when we run pyfile1, we should see each line of infile, which has the contents of hello. So if we cat infile, you'll see that it says that the contents of infile is hello. We're going to print out each letter line by line. So python3 pyfile1.py. There we go. So we successfully read all the data within infile. And you'll notice here that we have 1, 2, 3, 4, 5, 6 bytes. And if we run ls-al, you'll see that infile is indeed 6 bytes in length. So we can read a file. Can we write a file? Let's try writing a file. So we're going to make our second program here. Nano, let's call it pyfile2.py. I'm going to paste this in. So what's going to happen is we're going to read the infile as read in binary, and we're going to open something called outfile, and we're going to open it as writable binary. We're going to read from infile and write it to outfile. So essentially what we're doing is copying an entire file. Control X to exit, save modified buffer, Y, yes, enter. Now we'll run python3 pyfile2.py, and let's see what happened. We print it out again. However, if we run ls, we'll see that there should be an out file somewhere. Oh, there it is. So as you can see, we have infile and out file. And if we read the contents of out file, we'll see it's a copy of infile. So now we know how to read and write from files. So let's do flag VP110.18 together. We're going to download this file. If you're on Windows, I'd recommend just using your web browser, downloading it. If you're on Linux or using one of the cloud machines, we're going to use a program called wget. If wget is not installed on your system, you can install it by typing sudo apt install wget. It should already be on my system. So let's type wget and the URL. And what this is going to do is just dump that file right here. If it can resolve samclass.info. There we go. Aha, there we go. So we should have a VP110-1 file. Where is that? There we go. So here it is. It is 283. Wait, no, that's not it. Oh, here it is. 9.8 kilobytes, VP110-1. So what are we supposed to do with this? So we got that file. Count the number of backslash of. So the file has a bunch of random bytes in it, and we have to count how many of those bytes have the hexadecimal value of 8. So let's try this. We're going to copy this shell code, and we are going to make a new Python file called, let's call it vp110-1.py. We're going to paste in that shellcode again. And actually, we don't need to read anything. We don't need to write anything. I'm sorry. We just need to read. So we only going to convert all these to tabs because remember I said that the trick with Python is that if you have one programmer that likes spaces and another that likes tabs, you can find yourself in some issues. Tabs says, Sam says, who uses tabs? So we're going to read in, instead of in file, we're going to read vp110-1. That's our file. And we're going to keep reading in bytes. And we're going to have a counter. So we're going to make a variable here called counter. We're going to set it to 0. So we don't need to print the byte. We certainly don't need to write the byte. However, we want to create an if statement. So if byte equals xxx08 colon counter equals counter plus 1. So we'll increment the counter every time we encounter the byte that is, you deleted, I still have that line. Look, Sam, bytes f dot read equals 1. Oh, before the while. Oh, I did delete that line. You're absolutely right. There we go. We should have byte equal. Thank you, Sam. Yes, some of us know not to use tabs. Yes, the good programmers. Yeah, so you would think tabs would be the preferred way of doing programming, but it turns out that a lot of the really good programmers prefer spaces. And of course, Sam is one of the great programmers of all time, as he will tell you, I'm sure. Save buffer, yes. Enter, and let's run it, Python 3. vp110.py. Let's see if we get any errors. We didn't get any errors, but you know what we forgot to do? We forgot to output our results. So once we're done with the loop, we're going to print our counter. Press X, Control X to exit, save, Y, enter. Now it should work. Python 3, vp110.py. There we go. Now we know how many bytes of hexadecimal 8 are in that file. And we can confirm this too if we were to do something like xsd, which is the hex editor in Linux, vp110-1. So we're going to look at all the hex values in here. Then we will grep for 08. Never mind. Actually, I think there's a better way to do that. I don't know. But you can manually go through and count them all somehow. Throw it into a text editor, count how often 8 comes up, etc. I'm sure there's a way to do it from the command line. I'm not motivated enough to do that right now. But let me go grab that code again so you can take a look at it. Nano vp110-1.py. Here we go. And then we have a few more problems to do after that. We can add files together. So we weave bytes from 2 different files into another file. And then we can, and this is going to involve converting between bytes and integers and back to bytes again. And then we will add 2 bytes, 2 files together here. And I do recommend reading the references below of how to convert bytes to ints in Python 2.7 and 3.x below.
All right, I'll stop the recording.